Hello student, welcome to our first lesson in this topic where we are going to look at heat capacity, specific heat capacity and their units. We start with the definition of heat, and heat is defined as a form of energy that flows from a body to another due to temperature differences between them, which implies that if two bodies have the same body temperature, that is, you take a body that is having 20 degrees Celsius and another one that is having 20 degrees Celsius, there will be no flow of heat energy. And those two bodies, when they are having the same heat temperature, we say that they are at thermal equilibrium. So the flow is occurring due to temperature difference. Now, when a body absorbs heat, then the temperature of that body rises. While the body losing heat, the temperature decreases. So the absorption results in the temperature rise, while the loss of the same results in fall of temperature. Now let us look at the differences between heat and temperature. One, heat is a form of energy that flows from one body to another due to temperature difference, while temperature is the degree of hotness or coldness of a body, and this is measured on a scale. Then, when we are measuring the heat, we use joules as the SI unit. But in temperature, we have Kelvin as the SI unit. Then from there, after reminding ourselves about heat, let us move to heat capacity. And the symbol of heat capacity is capital C. Now, this one is defined as the quantity of heat required to raise the temperature of a given mass of a substance by 1 Kelvin or 1 degree Celsius. What does that mean? You have a body that is maybe having a mass of 20 kg and a temperature of 20 degrees Celsius. The amount of heat that you supply for the temperature to raise to 21 degrees Celsius is what we are calling as heat capacity of that particular body. So that energy that is required to raise the temperature of a given mass by just 1 degree Celsius is heat capacity. So mathematically we can say that heat capacity is given by heat energy absorbed or heat energy supplied divided by the temperature change. That is, C is Q over change in temperature. From this formula, you can make Q the subject of the formula by multiplying by the change in theta. So our Q is equals to C change in theta. The SI unit of heat capacity, as you are going to see here, the heat capacity is energy divided by temperature. And the energy, the SI unit of energy is joules. And the SI unit of temperature is degrees Celsius or Kelvin. Therefore, the SI unit of heat capacity will be joules per Kelvin, written as this J, K, all per K, where K is our Kelvin. Note that the different materials have different rates of heat absorption, and therefore, we have different heat capacities for different materials. Then we proceed to examples. Calculate the quantity of heat required to raise the temperature of metal block with a heat capacity of this one from 20 degrees to 60 degrees. So we want to calculate the amount of heat required. We have seen that Q is equals to C, where C is heat capacity multiplied by the change in temperature. So after writing the formula, you're supposed to substitute the values. Your C is 600 joules per Kelvin, and the change in temperature will be from 20 to 60. You get the change that gives you 40 degrees Celsius. When you multiply, you find that it is 24,000 joules. Then from there, we can move to specific heat capacity, small c. Now this one is the quantity of heat required to raise the temperature of a unit mass of a substance by 1 Kelvin. Remember now, when we are talking about the heat capacity, we are talking of a given mass. But now here we are specific. We want a unit mass. So you have 1 kilogram and then you want to see the energy that is required to raise that 1 kg, but the temperature of that 1 kg by 1 Kelvin. So that is what we call specific heat capacity of a body. So mathematically, we can say that specific heat capacity will be equal to heat absorbed or heat supplied Q divided by mass multiplied by the temperature change or change in temperature. In other words, we can say that specific heat capacity is heat capacity divided by the mass. So we have C, that is small c, is Q, then mass and change in temperature. Where now we can be able to get the value of Q as mass multiplied by the specific heat capacity, and then you multiply by change in temperature. That will give you the heat energy absorbed or heat energy supplied. The SI unit of specific heat capacity as shown here will be equals to the joules because of the energy, then per kg because of the mass, per Kelvin due to change in temperature. That is joules per kilogram per Kelvin. And this is the symbol. Then from there, specific heat capacity can also be expressed as follows. That is, specific heat capacity is equals to heat capacity, capital C, divided by mass, which implies that heat capacity, this part, will be given by specific heat capacity, small c, multiplied by mass. So that way, it implies that given specific heat capacity and mass, you can be able to get the heat capacity of a body. From there, note the following. If two substances of the same mass are subjected to the same amount of heat, they will acquire different temperature changes because they have what we call different specific heat capacities. For example, the specific heat capacity of iron is 460 joules per Kelvin per kg. That means that 1 kilogram of iron would take in 460 joules of heat when the temperature changes by 1 Kelvin. That is what it means. It has 460 joules per kilogram per kg. Therefore, if you take 1 kilogram of iron and you raise it, or you raise the temperature of that 1 kg with just 1 Kelvin, then the energy that body will absorb is equal to 460 joules. We'll look at an example. A block of copper of mass 10.0 kg and specific heat capacity of 460 joules per kilogram per Kelvin cools from 80 degrees Celsius to 40 degrees Celsius. Find the quantity of heat given out. We proceed as follows. We have seen that Q is equals to M, that is mass, multiplied by specific heat capacity, then multiplied by change in temperature. Now, we have our values. Our mass is 10 kg, that is given. Our specific heat capacity is 460, and the change in temperature is 80 to 40. That gives you 40. When you multiply, you get that our Q is 184,000 joules, or what we call 184 kilojoules. Then we look at another example. Find the final temperature of water if a heater source rated 50 watts heats 100 grams of water from 25 degrees Celsius in 5 minutes. You are given that the specific heat capacity of water is 4,200 joules per kilogram per Kelvin. We proceed as follows. The quantity of heat given by the heater is power times time. And remember, time is in minutes. We have to convert this in seconds. We must work with SI units. That is our power 50 multiplied by 50, 5 minutes, then by 60 to make them in seconds. And then we are saying that power is, Q, that is quantity of heat, is power times time. So when you multiply, you get that the Q, or the temperature, or the heat energy that is being supplied by this heater is 1,500 joules. But remember, we are supposed to get the final temperature. So Q is equals to MC change in theta. So our 1,500 joules will be equal to the mass, that is 0.01 kg. We have converted this into kilogram. Then multiplied by specific heat capacity, that is 4,200 joules. And now we are told that it is being heated from 25. We are looking for the final. So it will be capital T minus 25. We have that if you multiply this will give you 42, and this is 1,500 joules. So to get this part, T minus 25, you divide through by 42. And when you divide, you get that it is 35.71 degrees Celsius. Now to get T, you take 25 on the other side, so you add. After adding, you find that the final temperature will be 60.71 degrees Celsius. Then from there, we move to another example. A block of metal of mass 1.5 kg, which is suitably insulated, is heated from 30 degrees to 50 degrees Celsius in 80 minutes and 20 seconds by an electric heater coil rated 54 watts. Calculate 1, the quantity of heat supplied by the heater, and 2, the specific heat capacity of the block. We proceed as follows. We have seen that the power or the energy that is applied by the heater is always given by the power times time. We are given the power as 54 per second, that is 54 watts, and the time is 80 minutes. We have it here, 80 minutes and 20 seconds. So we convert 80 minutes to seconds, that is 80 times 60, and then we add 20 seconds. You get that the total time will be 500 seconds. Now our quantity of heat will be 54 times 500. You get that it is 27,000 joules. That is the energy or the quantity of heat supplied. Then part B, we want to get the specific heat capacity. We use this formula. Q is equals to MC change in theta, where M is the mass, C is the specific heat capacity, and change in theta is our change in temperature. So we substitute our values. We have this as the energy, 27,000. We have mass as 1.5 kg, and the temperature is changing from 50, or it is being heated from 30 to 50. So we can be able to get the change in temperature. So what is our unknown is our specific heat capacity, C. So we have, if you multiply 1.5 and then you multiply by the change, that is 20, you will get 30C. So it implies that 27,000 is equals to 30C. To get C, you divide through by 30. So 27,000 divided by 30, you get that it is 900 joules per Kelvin per kg. That is our specific heat capacity of this block. From there, we have the assignment. The assignment is testing what we have just covered. So be positive and always look forward to get better results. Thank you, and let us meet in our next lesson.